Hello and welcome. In this video, I will teach you the fundamentals of NVIDIA's AI infrastructure stack. So without further ado, let's get started and look at the objectives. So I'll first talk about what is an AI infrastructure and why do we need it. Why is it that traditional infrastructure not sufficient to run the AI workloads? So we'll look at that. And then secondly, I'll explain you about what is an AI factory, right? Because NVIDIA talks about it a lot. So what is an AI factory? We'll look at it. And third, I'll introduce an AI infra mental model that I have created so that you can understand and remember the capabilities of these NVIDIA infrastructure well. And then fourthly, that infra model can be broken down to different layers. So the first layer of that model is compute layer, where I'll talk about GPUs, CPUs, and DPUs. And also I'll give you an analogy using which you can remember the functionality of these three capabilities well, because it could be quite confusing as to remember what exactly CPUs does and what is it that GPUs does and what is it that DPU does. So I'll give you an analogy using which you can remember and explain anyone how these three offerings differ. And then fifthly, I'll talk about data layer. When it comes to data layer, I'll teach you about data platform, that NVIDIA's data platform, and then GPUDirect Storage. And then uh, when it comes to networking layer, I'll teach you about NVlink and NVSwitch. And in fact, I'll show you how is it that NVIDIA is giving massive speed using these two technology stack like NVLink and NVSwitch. So I'll show that to you uh, with, with an example. Okay, and then we'll also talk about InfiniBand. And then when it comes to system layer, I'll explain you about DGX, HGX, and MGX, which are full-fledged offerings from NVIDIA to run AI workloads and SuperPod as well. And most importantly, I'll talk about Vera Rubin platform. This platform is a hot product from NVIDIA right now, and many big players in the market like OpenAI, Microsoft, Google Cloud, AWS, they are buying this product from Microsoft and running their own workload there. So Vera Rubin platform is a full-fledged offering from NVIDIA to run your AI workloads. So NVIDIA right now, besides just selling individual components like GPUs, CPUs, and DPUs, is selling fully integrated, full-fledged system like NVIDIA Vera Rubin platform, which you can use to run your workload, right? And then uh, we'll talk about the I'll explain you about software layer, that is libraries and frameworks that NVIDIA offers, using which are vital for you to run your AI workloads. And then I'll teach you about the deployment environments. Where is it that all these workloads will be deployed? Is it on cloud, is it on-prem, or both hybrid? And then will the I'll give you the final takeaways of this video. So there is a lot to learn, a lot of informative stuff coming up. So I strongly encourage that you watch this video till the end, because by the end of this video you will be in a position to explain the fundamentals of NVIDIA AI infrastructure to anyone. In fact, you yourself will have a deep understanding about the entire technical stack. All right, so let's get started. Right. So why do we need an AI infrastructure? Let's get back to November 2022 when ChatGPT was launched. So before the launch of ChatGPT, there was general purpose computing. So what used to happen is there were workloads like databases, emails, or enterprise workloads like CRM or ERP. So to run all those general purpose workloads, um, CPUs are enough. And one thing that's centric to these general purpose workloads is retrieval, right? So for example, database, right? Database retrieves or fetches the data. And you might say, no Jabbar, besides fetching their data, uh, databases do write data as well to the database. You are absolutely right. Yes, databases do write operation, but those write operations are input driven and schema constrained. There is a schema that's already defined, and within which whatever you write go ahead and get stored. So what general purpose computing do is they run applications and operating systems, right? That's what they do. But post the launch of chat gpt, there is whole new world of accelerated computing emerged. And there is and this these workloads are quite heavy in terms of training and inference, right? They demand a different sort of hardware altogether. That's where the AI infrastructure has emerged, and that's the reason we need a different sort of infrastructure to cater to this inference and training of workloads. And this is quite dynamic. It's not schema constrained or input driven. It's completely different. It's huge. And that's the reason we need a different sort of hardware altogether. And this slide talks about that particular hardware. If you look at the left side of the slide, this slide tells you the difference between AI infra and general purpose infra. So AI infra is standard 9. Oh, sorry, the general purpose infrastructure is standard 19 each rack, and most importantly, it's low density. So what I mean by low density is CPUs. There are fewer CPUs that are spread across the rack, right? And that's the reason the density is low, and the heat would also be low. And that's the reason air cooling is enough to cool down these servers. But if you come to the right side of the picture, you would see an in AI infra where you have GPUs. So we need GPUs to run the AI workloads. Now, why do we need GPUs? I'll explain in the upcoming slides. But the point here is, at this point of time, we need GPUs because GPUs are the capable. They have the capability to run the AI workloads like training and inference. And these GPUs emit a lot of heat, and they're highly dense, as you can see here, ultra high density. There are a lot of GPUs can be accommodated within a single rack, so they emit huge heat, and to cool down that heat we need liquid cooling, right? And that's what you can see on your screen, liquid cooling manifold, where you have pipes here using which liquid is being sent to cool down the chips. And then we need huge amount of bandwidth to cater to the AI workloads. That's the reason you see here high bandwidth interconnect, and I'll explain you what those interconnects are in the upcoming slides. So the one takeaway from this slide is AI infrastructure emits a lot of heat, and to cool down that heat we need liquid cooling, and the AI infrastructure is highly dense. What I mean by dense is huge, or many number of GPUs can be accommodated into a single chip. And 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 GPU is the only capability or only product that can cater to the AI workload, or the AI math that models do. Right. So, what is an AI infra? AI infra is everything required to turn raw data into intelligence. That's what AI infrastructure is. That includes collecting and storing data. Right. You need data to train your model. So, collecting and storing data is the first thing, and then you train your AI models, and then you deploy your models once you train them, and then running inference at scale. So, once your model is deployed, inference happens. So, when customer gives a prompt, AI workloads or AI models respond to that, and they do it by inferencing. And then there is a monitoring, securing, and optimizing models over time. Right. So the key idea is AI is not a single system; it's a pipeline. Now we'll look at this now. AI is a pipeline, not a magic. So as I said, ingest data. The first thing is you ingest data, and then you train model, and you deploy model, you scale and inference, and monitor and optimize. So this is the entire pipeline using which the end-to-end AI system is established. So the weak link theory: if one link breaks, intelligence fails. So all of these things are extremely important to run your AI workload. If one fails, the intelligence fails. Okay, now moving on, let's talk about an AI factory. So what is an AI factory? So NVIDIA describes this entire pipeline that I've shown you as an AI factory. This is what NVIDIA says. NVIDIA says an AI factory is a specialized computing infrastructure designed to create value from data by managing the entire life cycle, right? Entire AI life cycle, from data ingestion to training to fine tuning and high volume AI inference. So what is the product of this? So factory, right? Let me bring this up, right? So if you look at this 19th century, factories, it was an industrial revolution, and there is the age of factories. So the product was physical goods, but the input was energy plus materials. So energy and materials used to get supplied, and the outcome was physical goods. But in terms of AI factory, electricity is the input and the data, and the output is intelligence that's measured in token. So just as 19th century factories used energy to manufacture physical goods, AI factories use electricity and data to manufacture intelligence that's measured in tokens. Hope you've got clarity now as to what exactly is an AI factory. Now, let's talk about the AI factory's mental model. Is a mental model that I have created. So this is a model that I want you to remember to, you know uh, create a picture in your mind as to the different offerings or different products from Nvidia and where exactly do they fit in this entire layer. So there is a data layer, right? And then there is a compute layer, network layer, systems layer, and software layer. So whoever builds all five layers controls the performance, and Nvidia has offering across all these layers, and we'll look at those offerings and we'll look at those products shortly. So let's look at the data layer, the fuel for AI. So what's the purpose? To ingest data, process and feed massive data sets to the GPUs with zero bottleneck. So the purpose of this layer is we want to give or ingest data, so that that data can be used to train models using these GPUs. Okay, so what are the key products here? What is it that NVIDIA offering in this layer? NVIDIA AI Data Platform. NVIDIA Data Platform is the platform that NVIDIA is offering in this layer. It's an enterprise class infrastructure designed for AI or agentic AI workloads. That's the first thing. The second thing is a Magnum GPU direct storage. So what happens is, to understand this thing, what exactly is the GPU storage, direct storage, and the significance of this. Look at this diagram without GPU direct storage. What happens is NVMe. This is NVMe, as you can see here. So NVMe, that stands for non-volatile memory express. So this is basically SSDs, solid state drives, huge amount of storage drives. So using these storage, if obviously GPUs are the thing that do math or that do those model trainings. So when data used to pass, what do you what should happen in case of without GPU direct storage is it should hop to this CPU memory as well. As you can see, this is a orange line going to CPU memory. So this introduces latency, but with GPU direct storage there is no need for this hop. The data can directly go to GPU, as you can see with this green arrow, and that's what it's written here. GPU direct storage enables a direct path between storage and GPU memory and avoids extra copies through a bounce buffer in the CPU's memory. There's an extra copy via this bounce buffer, and same thing is more illustrated by this diagram as you see on your screen. The traditional bottleneck was the CPU, because there used to be a hop here, and that would reduce the speed and this would introduce latency. But with NVIDIA GPU direct storage, this has gone, and storage directly talks to GPU memory, right? All right. So that's the first thing, data layer. Now let's look at the compute layer where the AI math happens. So CPUs. CPUs, NVIDIA Grace CPU super chip. This is NVIDIA is the product that NVIDIA is offering in this layer. Grace CPU's chip. So CPUs are good at the control logic, right? CPUs control logic, like even in traditional world before the launch of ChatGPT, CPUs were there. They're good at running operating system. They're good at data pre-processing, scheduling, and orchestration. They do pretty well here. But CPUs are not optimized for large matrix multiplication, deep learning workloads. That's what I try to explain here in this slide. Where do CPUs fall short? CPUs are good at serial processing, right? They do operation one after the other. But when it comes to massive parallelism, massive task at once, that's what math requires, which we do when we train or inference the AI workloads. CPUs are good at, right? So let me give you an analogy now, as I promised before. CPUs, think of CPU as brains, right? They think, decide, and coordinate. And GPU as muscle. They do heavy lifting like math, AI. And then DPU is like the body's reflexes and circulation system. And I'll talk about DPUs in a bit. Hope you are able to get along and understand the difference between CPUs and GPUs so far. Now let's look at GPUs. So modern AI exists because GPUs exist. Let's be honest here. So why GPUs dominate AI? As I said, they provide massive parallelism, meaning you can do multiple operations at once using GPUs, and they provide tensor cores designed for AI math and high memory bandwidth. Since you are able to do multiple operations at once, that also means you have high memory bandwidth. Now let's look at few GPU architectures. Right, this is NVIDIA Blackwell architecture, the latest and greatest architecture from NVIDIA right now. So GB here stands for GB, stands for Grace Blackwell. This was released in 2024, the latest offering from Microsoft, sorry, NVIDIA. And then let's look at this is NVIDIA Grace Hopper GPU. This was named after a scientist called Grace Hopper, and this was released in 2022. Now, so far we've learned about CPUs and GPUs. Let's learn about DPU. So, what is DPU? DPU stands for Data Processing Unit. Is a smart network card that can run its own programs and take work away from the CPU. um, so what exactly is DPU saying doing? Let's look at that. So this is NVIDIA Bluefield platform. It's a flagship offering from NVIDIA in the DPU environment, in the DPU field. So modern data centers are overloaded with infrastructure work. So what DPUs do is they offload networking, security, and storage processing. So they offload these tasks from CPUs and GPUs. So result is, what's the result of this? CPUs and GPUs focus on AI and better isolation for a multi-tenant environments. So this is what DPUs do. They offload networking, security, and storage work from CPU. So CPU and GPU can focus on running the AI workloads. Now let's look at NVIDIA Grace CPUs and superchips. This is another offering from NVIDIA. As GPUs got faster, CPUs became the bottleneck, right? So CPU had to keep up with the pace with the pace GPUs were being developed, and that's when NVIDIA's response was Grace CPU, designed specifically to feed GPUs, right? And then Grace Hopper Superchip is a super chip where CPU and GPU were tightly integrated. This is NVIDIA's Grace Hopper CPU, designed to feed GPUs. And then this is Grace Hopper super chip, as you can see on your screen. CPUs and GPUs are tightly integrated. So hope now you understand the Grace Hopper super chip that tightly integrates and CPU and GPUs together. So what NVIDIA did is NVIDIA didn't just accelerate AI, it re-architected the whole compute node. Now let's look at the interconnects. So let's be very honest. No? One GPU isn't enough for modern models, right? One GPU is not enough to run your all models, huge amount of or trillion parameter models. That's when NVIDIA has come up with these interconnects like NVlink, NVSwitch, and then traditional PCIes. We'll look at them each, what they are. So PCIe, Peripheral Component Interconnect Express, that it stands for. So PCIe stands for Peripheral Component Interconnect Express. It's a high-speed serial expansion bus standard used for connecting a computer's motherboard to internal peripheral devices. So but PCIe has got its own limitation, and that's when NVIDIA has come up with NVLink and NVSwitch. Now let's look at NVLink and NVSwitch. It's an ultra high speed GPU to GPU communication. So as I said before, one GPU is not enough, so you need to have multiple GPUs connected so that um, task can be spread across this GPU and huge amount of operations can be done at once. That's what NVLink and NVSwitch allow you to do. They allow you to connect multiple GPUs together on a ultra high speed network, makes many GPUs behave like one giant accelerator, and this is what enables trillion parameter models. Now let me talk about in detail about NVLink and NVSwitch. So in theory what happens is two GPUs could run a model two times faster. and 4 GPUs can run 4 times faster, and 8 GPUs can run 8 times faster. And that's what I'll try to show you in this screen. So this is multi GPU configuration without NVSwitch. So there is no NVSwitch here, and you can see there are 8 GPUs trying to talk to each other, and you can see the way it's happening. Now, but what happens when NVSwitch come into picture? So this is NVSwitch, and there are multiple GPUs, 8 GPUs again trying to talk to each other, and as you can see on your screen, so NVSwitch has streamlined this entire communication process. Now you might be wondering here, what's the difference between NVLink and NVSwitch? So NVLink is this physical wire, right? It's not only this physical wire, it's also the protocol that GPU use to talk to each other. But whereas NVSwitch is this really a switch, this is hardware that NVIDIA has created that streamlines this connection of multiple wires and connection of multiple GPUs together. So let's see what happens, how the speed improves without NVSwitch and with NVSwitch. So without NVSwitch, as you can see, the speed with which one GPU used to talk to each other was 128 gigabytes per second. Right? The total processing time was compute per comms. So computation and then communication. That's the total processing time. That was so without NVSwitch, the speed between the two GPU is, or the bandwidth between the two GPU is 128 gigabytes per second. Now let's see how that bandwidth increases with the introduction of NVSwitch. So with NVSwitch, as you can see on your screen, the bandwidth has gone ahead to 900 gigabytes per second. That's huge, right? That's huge because and you can also see that without NVSwitch, the total processing time was compute probably for about 80%, and remaining was for communication. But with NVSwitch, the communication time has really gone down, and therefore it's just the compute time that the GPUs are taking. So this is about NVLink and NVSwitch. Hope this you have found this helpful, and hope you have got clarity as to how NVSwitch is really accelerating the connectivity between two GPUs or multiple GPUs. Therefore, that's resulting in the improved speed and lowered latency for AI workloads. So that's it for this video, but in the next video I'm going to cover the remaining stuff like network layer and other layers that I've shown in the introduction. So see you in the next video.